Is this on? Yeah, okay. So today we have two goals. Whatever, I don't know what all this is. Our goals for today are DX. First is we want to click and drag. Actually, let's make it 3 goals. I just thought of one. Click and drag to rotate view, mouse wheel to zoom. I wonder if we're going to implement zooming. I wonder if we should clip polys before drawing. I've done that before, but I forget the details. And what was my other goal? Oh yeah, this one's going to be the big one for today, which is determine polygon / edges. Well, whatever, let's just say polygon under cursor. Okay, so let's begin. So the first thing I want is, I'm just going to copy this from Khan Academy. We may as well start these at 0. And let's actually well, nah, let's just keep it simple for now. I was thinking of having it detect like focus and stuff, but we don't need to do that. So I'm going to need a couple of helper functions. Let me think about this for a second. Thinking. How do you capture the mouse position? Yeah, this is something I remember, is you can only get it from oh, sorry, you can't see that, I just realized. Hold on, let me drop that in. Yeah, what I was saying is, I'm pretty sure that you can only get the mouse position inside of an event, right? Oh, wait, maybe not. All right, let's just try that out. So just to be sure here. Yeah, okay. And what the heck does that do? Undefined. Oh. Oh. Well, then what is this? Oh, that's from Element. Direct. XY width height, top right, bottom left. Yeah, alright. And then so I know there's two ways to add events to stuff. Yeah, that's right, on X, Y, Z. I don't understand this. Oh, whatever. I don't really care. So so what event should I use? JS list of events. Oh, what's the string? Oh, here we go. Here we go, the mouse. Oh, element, okay. Oh man. Mouse down, mouse enter, mouse leave, mouse move. That seems useful. Mouse wheel. Alright, let's do some stuff. So let's do CVS dot add event listener mouse move. Now, an object that receives the event listener callback. Yeah, that's okay. Callback or an object is handle event. Now I know there's a way to like disable all further events. Not that I need that though. I mean, I'm just kind of curious though. It's the kind of thing I would want to know. JS capture event. No, JS prevent further events. Yes, stop propagation. What the heck is capturing and bubbling? Man, capturing and bubbling. Right, that's obvious. Oh wait, hold on. Does it hit all of them? It does. Oh my god. I didn't know that. So oh my god, what is this? There's another phase of event processing called capturing. It is rarely used, but sometimes can be useful. Whatever, I don't care about this. Prevent default. And this sounds familiar. Stop immediate propagation. Yeah, okay, there's some way to do it. Anyway, this is why I never finish my projects, because I'll find something unrelated and just, yeah, so. Oh my goodness, okay. Client X, client Y. Offset X, offset Y. Man, this is, oops. No. I'm trying to get it to be 0, 0. Oh, what is this movement X, movement Y? Oh, offset X. What? Oh my god. The x coordinates of the mouse pointer in local coordinates. well. I'll delete this, I just need to know. Hello? Where is it? Oh. What the heck is let? Now what? Where's that paragraph? Okay. Now, what happens if on this paragraph I do yeah, you see, that's not what I want. Okay. Oh, wait, did I get rid of that? Oh, right, I actually need to type it in here. Let's actually just do mouse click or something so that it doesn't fire every single time. Oh, mouse down. I wonder if there's a way to just get... Anyway. got a 1 pixel border, a 10 pixel margin. I don't understand. Screen X 19, that makes sense to me. So then why is client X 18? I don't understand. And what is offset X? And what is movement X? Good God. Oh, because that depends on the scroll. But then what's paid? Oh God, why is this so complicated? Oh my God. Okay, so I guess I don't want client X, and I guess I don't want screen X either. I want the coordinate inside. The X coordinate of the mouse point relative to the position of the padding edge of the target node. What the heck does that mean? Between that event and the padding edge. What? What's movement X? Oh, that's actually kind of useful. Page X. Oh my God. What if I do this? Okay, client X19 makes sense because we have, wait, no it doesn't. Oh, right, hold on. So the margin is 8 pixels on the body. I've got a margin of 10 pixels on the canvas and a border of 1. So 10 plus 8 plus 1 is 19. Okay, yeah, and this is a 0 index coordinate as usual. Offset X. Well, this time it's 0. Oh, did I click the border last time? So if I click the border, yeah, the offset is -1. Okay, the offset is what I want, actually. Finally. But I don't. Man, why does everything have to be so difficult? Man, I can't find anything. Whatever. I can work around it, even though I think it's dumb, but what we're gonna do is, no, hold on. If e dot client x is less than CVS, no, is less than or equal, oh no, is less than 0, or e dot client x is greater than or equal to CVS dot width, or e dot client y is less than 0, or e dot client y is greater than or equal to CVS dot height. Then just return. Now what we will do is p mouse x equals mouse x, p mouse y equals mouse y, mouse x equals e dot client x, and mouse y equals e dot client y. And then in here, also gonna put this in here so that it just updates on every frame, because that's just better. Okay. And now in here we can do CVS dot add event listener mouse move for update mouse. Now, this is not something in Khan Academy, but I would find it useful. Only happens once per frame, so who cares? Oh no, actually it happens once per event, but also who cares? I mean, mouse move events happen at the speed of a human, so. Okay. What am I missing? What? Oh, actually, I'll bet you. I mean, I'm gonna add brackets anyway, but it's probably because I'm using the French keyboard, and it actually inserts an alternative space if you hold Alt while you're hitting the space bar, which is really frustrating. Alright, yeah, that was the problem. Well, or maybe it was this brackets, I'm not sure, but... Okay, that still works. Now that we have the mouse, we don't have to do that again. And one thing I need here is var. You know what? I'm not going to rewrite this. I've written this same function like dozens of times in my life. I'm just going to find a place where I've written it before and reuse it. But I'll at least explain it once I paste it in. Just gotta find it here. Okay, so what did I just paste in? Well, just some, I mean like, oh, I need this mag function. It doesn't exist, does it? Fine. Wait, what is it? Okay, now this is doing some stuff, whatever. I don't need these. So, alright, let me explain here. So, when you're doing 3D programming, there's this trick. Apparently there's some deep math behind it, but I never understood the deep math part of it. I just know that it's a trick you can do. But you can represent any translation, rotation, and scaling using a 4x4 matrix. There's no way I can explain this well just sitting here. How do I explain this in a way that would... it's just a big topic. All right, let me explain it like this then. When you're writing a 3D engine, your goal is to take points defined in 3D space and draw them on the screen. Well, sort of. You see, the thing is, the vertices that define this chick were designed once in Blender and then written to a file, right? Now, if, say I had like 10 chicks in the screen and I wanted to draw them walking around all separately from one another, I would need to move each of the chick, like this vertex here at the tip of the beak is like, I don't know, like 111 or something, okay? It's like 1 or 1, well, now I have no idea what this coordinate is, but let's say it's 111. Well, if the chick moves in the world, then I need to move this coordinate, and by the way, all the other coordinates in such a way that the whole chick, you know, moves, okay? Now, one way to do that is to just write a bunch of ad hoc code. Oh, well, if I translate a vertex, then what I'll do is I'll just take all the vertices in this shape and move them. And then what if I'm rotating it? Well, I can eventually figure out, you know, a function that'll rotate all the vertices. And then what if I scale it? In other words, make the chick bigger or smaller? Well, I can write a function that can kind of do that. But it turns out there's a sort of a more general way which improves performance. It so happens that translation, rotation, and scaling, and also, by the way, shearing, can all be represented as a 4x4 matrix multiplication. So the trick is, I don't want to get into detail, so I'm going to stop myself before I actually sit down and draw example matrices. But because I can represent a translation as a 4x4 matrix and a rotation and a scaling, each as a 4x4 matrix, if I have multiple transformations to do on the shape, I can actually pre-multiply all my matrices together to make one final 4x4 matrix. And then that 4x4 matrix multiplies the vertex and translates it. But you might be thinking, well, hold on, all of my vertices are three-dimensional. How do I multiply a three-dimensional vertex by a four-dimensional matrix? The answer is simple. Just put 0 as the fourth coordinate of, or no, put 1 as the fourth coordinate of the vector. Now, the deep math behind it is, what we're doing is we're taking our 3D points and we are embedding them into a four-dimensional space with z coordinate 1. Or something, or w coordinate 1. Like, I don't know, okay? There's something about like Euclidean geometry, projective geometry, circular geometry, something geometry, okay? Just, I can't explain it because I don't understand it. It's just something I've done before, and it's just a little frustrating. So let me explain this comment here. I use the 4x4 matrix trick, in other words, this trick of embedding your 3D points into a 4D space to be able to represent translations. But I have optimized all these functions to assume that the vector W components are always 1, because that's what I always do, and that the bottom row of all matrices is 0, 0, 0, 1. This is just something that I noticed. If you take a translation, a rotation, or a scaling and make it into this 4x4 matrix, you'll find that the bottom row is always 0, 0, 0, 1. So that means that even though this matrix has is 4x4, I actually don't need, notice here that the highest index I ever use in that matrix is 11. I actually don't need like 12, 13, 14, 15. I never use them. I just assume that they're 0, 0, 0, 1. And also notice that for the vector, I never use an index higher than 2 because I assume that it is, well, I mean here if I was doing a real matrix vector multiplication, I would have multiplied by v3, but I'm assuming that v of 3 is always 1, so I don't need to write that, okay? This mat3 vector is just a helper function. It's a 3x3 matrix times a 3-element vector, nothing too complicated. And then this mat function here multiplies two 4x4 matrices with the assumption that they have 0, 0, 0, 1 as the bottom row. Or no, not with that assumption. Oh, yes, with that assumption, yeah. Anyway, so instead of a generalized 4x4 matrix multiplication, I squeeze out some extra performance by not multiplying by constant zeros or constant ones. Anyway, I'm not going to, I mean, I've written this code before, I don't need to write it again, so I've spoken my piece. Now, the next thing that I need is the functions that actually return a matrix. Yeah, so I mean, So I've got three functions here. Get yaw matrix. This spins around the y-axis counterclockwise by 5 degrees. Get roll matrix spins around the x-axis counterclockwise by 5 degrees. Oh, but this cosine is from Khan Academy. I need to figure out the JS math.cosine. Radians. God. All right, here's what we're gonna do. Now, there's also another function I have in here. I know I've done this before somewhere. Maybe it's not in this file I'm looking at. So it's spin around y-axis. So the z-axis is pointing into the page. Oh yeah, okay, yeah, that's right. Now, okay, now I remember why I only implemented these two, because it's actually all I needed. And yeah. Also, I don't like putting get in front of a function name. It's like the function returns something, so like why do I need to put that in the name of the function? Okay, now now hold on. I kind of want to center the model around 0, 0, 0. Well, it kind of already is. How do I do that? Ah, okay, I have an idea. I have an idea. No, I don't have an idea. Shoot. I'm only hesitating here because I'm trying to keep the code a little bit clean and not get into trouble. All right, you know what? Let's just do this a little incrementally. Let's just assume that the model's already centered around 0, and I'll just figure out how to do that later. So, you figure out a nice way to center model at 0. Well, no, it's more like figure out a nicer way to look at model, zoom, pan. Rotate around point right in front of the camera. Like, because I would expect, like, if you hold an object in your hands and you're spinning it, or like, okay, imagine you're holding like a weird kind of big object, like, I don't know, like, no, that's not what I want. No, that's not what I want. Oh, whatever. So let's say you're holding some weird object like this in your hand, okay? And you know, here's a human being for scale. It's a big object, and you're trying to, like, I don't know, you're trying to look at this part here. So what you're gonna do is you're gonna hold it closer to your face, and when you spin the object, you're just spinning it around this point near your face, right? What you don't want is there's like a, shoot, where is that? Hold on, I gotta find it. Here it is. So notice here that, yeah, I can spin it around and it's rotating around 0, right? Every time I move the mouse up, it rolls the shape, right, around 0, 0, 0. And when I move the mouse to the left, it yaws the shape around 0, 0, 0. Okay, but let's say, you know, I want to check the detail on the handle. First of all, I can't pan. Oh, I can pan. But now notice that all that happened here, like, the actual center of rotation is not on the shape, okay? This is like if I had an invisible stick that the pot was attached to and I was moving the pot at the end of the stick. Like, it's easier to see if I do. Actually, what is it rotating around? I can't even tell. It's rotating around some invisible point, right? This is not what you want. Like, if I zoom in on this handle and I rotate, like, I want to be rotating around the handle, not this weird invisible point in the middle of nowhere, okay? And so that's where things are getting tricky now, because now I'm doing something like, oh, well, select the center of rotation as, you know, the point that I'm looking at. Yeah, so anyway, that's now that I said it out loud, I think the more succinct way to put it is there's got to be a nice way for automatically picking the center of rotation so that it's user-friendly. But for now, I'm not going to do that, okay? For now, I'm just going to rotate it around 0, 0, 0. Now, so var model mat equals that. I might implement free look. It's not that hard, actually. But anyway. I also need a function. Actually, this is something I do need. Well, no. Well, it would be nice if I could normalize the matrix. Whatever. Let's not bother with that. And this is my problem. I got to do things more incrementally so that I don't have these huge ambitious ideas that I never finish. So here what we're going to do is so vertices transformed is no longer going to be just XYZ transform of Y. It's actually going to be mat vec of model mat and V. So for now, this should do nothing. Or in other words, it shouldn't break anything, it shouldn't change anything. Now what we're going to do, and I hope this works, is so var I don't know, roll equals roll mat of d mouse y. I think I need minus d mouse y here actually because it's counterclockwise. And var yaw mat. And I think I need positive e mouse x. Well, we'll see. If it's not right, I'll just flip the signs. But and now we will do model mat is equal to mat of roll and mat of yaw and model mat. I forget the order of the arguments to mat, but this should be okay. Oh! Okay, well, something's going on here. Fascinating. Okay, stop. Stop. Okay, hold on. That should only be happening when I'm dragging, not false. I'm just copying the Khan Academy API because it's really good. It's one of the best drawing APIs I've ever encountered. Well, I mean, they kind of stole it from processing.js, but the point is it's a good API. So now what I need is the button number that was pressed. Okay, we will do mouse is pressed equals e dot buttons and 1 is not equal 0. Does this work? Okay. Oh, right. I actually need to. This chick is having a hell of a day. If mouse is pressed, do all this. Otherwise, don't. Okay, it's really fast. Let's try slowing it right down. Well, 100th of a degree is probably a little too small. Wait, did that just make it worse? Oh my god. Okay, let's turn it right down there. Oh, that's better. So actually, yeah, that's the right direction. This is the right direction. Wait, is it? No, it's actually backwards. Fine. And I don't know why this is so friggin' fast, but whatever. A little faster would be good. There's probably like some magic number you can use. That it exactly tracks your mouse like this. Well, actually that doesn't. Hold on, let's just. How do you reset the. It doesn't actually. Okay, it's fine. It's fine. So let's just keep tweaking this until we're happy with the speed. It just doesn't, it just feels off. Something's wrong with it. I don't know why. Oh, I think my X is backwards. Or maybe this is because of that, like, okay, definitely my Y is backwards. I think I had it right the first time. Also, it's still a little too slow. Oh. Okay, that's too fast. Wait, that didn't do anything. What is happening? Wait, is this... Oh, okay, that is getting better, actually. Oh, that's why. We don't get another event if the mouse didn't move. So then how do you get the mouse position? Oh, but man, now we're really getting into some sneaky business. So I think I'd rather do it like this. Instead of inside here. I hate it when editors write code for me like that. It's like, why am I having to fix your syntax? You should stop trying to fix mine and I'll stop fixing yours. Can we have an agreement here? And we need to do the same thing here. I wonder if it'll complain that it can't. No, that's only Lua that does that. I think JavaScript can implicitly convert. Actually, JavaScript implicitly converts anything you want in ways that are often quite baffling. Okay, let's try this. Oh, that. What? Dude, what is this garbage? Shouldn't it? The button number that was pressed. What? Come on. Now stop. You know what? Just like, man, this is, I always get so frustrated when it's just Control Z, all this junk. It's like, why does everything have to be so complicated and surprising and all right, we're just gonna do this the easy way. There, you happy now? There, finally, I got this stupid thing spinning. Why did that have to be so difficult? So this is like a little too fast. There we go. Great. We can now spin our object. Good enough for now. Let's check that off the list. I don't know if I'll do the zooming today. Determine polygon under cursor. Yeah, this is tough. Man, I've already spent how long here? Over an hour just on this thing, which should have been easy, which would have been easy in Khan Academy. But for some reason, nothing is going to be easy for me today. Well, anyway. Now the next thing to do is figure out what polygon is under the cursor. How do I do that? Well, I know that the eye has a position. It's like 0, 0, minus 10 or something. And because I know the cursor's position, I know where to trace the virtual screen. So I have 2 points that define a line, and I want to return all of the polygons that that line intersects and then pick the one closest to the eye. I'll Google it in a second, but let me just think to myself if I can figure out a nice line polygon intersection formula. Or not intersection, but line polygon collision. Well, first what you can do is well, no, that wouldn't be nice. I was about to say, oh, we'll get the normal of the polygon and use the normal to subtract, like, imagine that the polygon is actually just a subsection of like a big plane that the polygon is contained in, and I want to get where the line intersects the plane. That's easy. You just subtract the rejection or you know, compute the projection. And then after that, there are points in polygon tests. I wonder if there's an easier way. Oh, well, yeah, there is an easier way. I can do it in 2D for starters. Because I've already in fact, I've even found the pixel coordinates already of all of my vertices. Oh, but when I do that, I lose the information about which polygon it is, because I'm just mushing it all down to 2D, and I'm even doing wireframe. I'm not even doing like backface culling or anything like that. All right, I thought about it enough. Let's look it up. Well, this shouldn't be on math.stackexchange. No, this only works for rectangles. Oh, I've seen this before. There's a paragraph on this, or maybe even a whole chapter on this in the Graphics Programming Black Book. Oh yeah, Foley, of course Foley is in the references. Well, yeah, okay, great. I'll just install Shapely, the Python library, inside my JavaScript program. I mean, granted, this person did put the Python tag on it, but you know. Man. Whatever, man, I'm done. It's like, when I get to the point where I'm just sitting here quiet, not thinking, not typing, hardly even looking at the page I have in front of me, it's like, nah, I should stop, or else I'm just not going to enjoy working on this project, and I'll just write bad code that I'll have to fix later anyway. So let's just go ahead and push this. Did I save it all? Yeah, it's all saved.